This is question 15 from PT75 section or logical reasoning section 1. So we're asking what would most strengthen the astronomer's argument. So we're going to want to identify our conclusion. And our conclusion, we might be strengthening it by filling in a flaw. We might be protecting the argument from weaknesses. It might seem really random, but we might be like just saying, okay, here's a reason why, we support the conclusion, even though it seems really random and not mentioned in our passage. So we're sitting here, we're seeing that in most cases, planet has been detected orbiting a star. The orbit is oval, whereas the orbits of Earth and planets are pretty circular. So we've got this idea of like, okay, the Earth and planets are, going around the sun, and we could use our own context here. We know the sun is a star. If we didn't realize that, they're going to be drawing a comparison between the sun and the star, and it looks um, like something puzzling. So we could also infer it from the passage in context that the sun is a peculiar type of star. So in most cases, we have an oval shape going on here, whereas with our normal or with our solar system that we know and love, this is not the case. We've got ovals versus, our current solar system orbit. However, many comets orbiting our sun have been thrown into oval orbits by close encounters with planets orbiting our sun. So basically, we've got all these different like little planets around here, and they've got like these circular orbits, and then we've got comets over here that now they've got like more of a like an oval orbit. I have no idea. So they say some of the planets in oval orbits around distant stars were probably thrown into these orbits by close encounters with other planets orbiting the same stars. So they're saying like they think something else is happening because they're comparing things with oval orbits around our own solar system, and like they're comparing our comets with the other solar system's stars. Okay, cool. So it seems like all these different planets are interacting with each other. And I have no idea if this graphic's even helpful. I don't even know what my graphic is looking at, TBH. But we're looking for something that's going to help our conclusion. And our conclusion is this idea that some of the planets in oval orbits were probably thrown into close orbits by close encounters with other planets orbiting the same stars. So that last sentence. And we get that because, our conclusion is the thing being supported by everything else. Our astronomer has created this argument to just kind of walk us through the process of, what's his hypothesis? How does this make sense? So we're looking for things that would strengthen this argument. We've got one thing that's going to strengthen it absolutely, and it might not be a very flashy answer, but there are going to be 4 wrong answers that either weaken the argument or don't do anything whatsoever. All right, so let's go ahead and look at this. A, when 2 planets or other large objects in orbit have a close encounter, usually the smaller of the two is the more greatly affected. So we don't really care about what is greatly affected, whether it's like which planet, or in the case of our own solar system, it's the comet and the planet. Um, Makes enough sense if we're thinking comet and planet, but when it comes to the other solar system, there's 2 planets. One's going to be affected more than the other. We don't really care about it, so this would be something that's kind of irrelevant. Cool though, cool fact. B, there is no indication that the orbit of any planet orbiting our sun has been affected by a close encounter with another planet orbiting our sun. So, I mean, that's kind of like, it doesn't really support our conclusion. We're looking for like more evidence in a way, or something that's really going to support. Here, they're just saying that sometimes it's the case that planets change comets into oval orbit. So some of the planets that are in oval orbits might have been caused or were probably thrown. They're saying like, okay, it's possible, not the only thing that's happening. So B is just a little too strong for us, and it doesn't really matter. um, doesn't really impact our conclusion. C, in most cases in which planets have been discovered orbiting a distant star, so this is opening up pretty broad so far, more than one planet has been found orbiting the star. Okay. So basically, they're saying, like, okay, we see things orbiting distant stars, and there's more than one planet. It'd be kind of hard for another planet to suck you into an oval orbit if there's no other planet. So what this answer choice does is it identifies a potential flaw or a gap in the reasoning. It identifies, like, this is kind of like the necessary assumption a little bit. And they're saying, most cases there's multiple planets, meaning that you can have a planet that's going to alter your orbit from a circle into an oval. This would really help us. But let's think about it. Like, what if this was not true? If it's not true, then it should weaken the argument. So if in most cases there's only one planet, that means that the astronomer's hypothesis or theory is completely wrong. So this is looking like a really nice answer choice. Um, D, most comets with an oval orbit around our sun were thrown into orbit by a close encounter with some other object. So basically, not a planet. This it's tricky because if they said close encounter with some other object, if they had said planet, it could have been a correct answer. But it says other object, doesn't have to be a planet. So this could potentially weaken our argument. We want to be really careful making sure we're reading the whole statement. Then E, for each distant star that has been found to have a planet, no other object large enough to affect the planet's orbit has been found orbiting the star. So this would actually strongly weaken our argument. So, like, if we have a star with a planet, there was nothing that could have created this oval orbit, meaning that even if there was a planet, maybe there was a planet got destroyed. Like, who knows? We don't have any large objects enough to affect the orbit. So it means it naturally probably was just in an oval orbit. All right. So this would totally weaken our argument, meaning C is the best answer to choose here.